how do we evaluate nth roots and use rational exponents? Well, before we even get into that, let's just think about how would we solve x squared equals 36?
You just square both.
Like,
Take the square root of both.
we would take the square root, right? So I know that x would equal not only the square root, but since it's an even number, it'd be plus or minus, right? And it would be the square root of 36. Now, and we could go through that and see that it's 6, blah, 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 blah. So let's just think, what if it was x to the n equals 36? Right? So look, whenever it was squared, we ended up taking the square root. So if it's raised to the n power, here what we do is we just take the nth root. Okay, but this is in radical form, and I'm going to show you how to write this in rational exponent form as well. So we're going to take these radicals and turn them into rational exponents. So the nth root of x, which is what I have right here, the nth root of x, this is the same thing as x raised to the 1 over n. Okay, this is how you would evaluate it. So as an example, if I wanted to take the third root of 5, I could evaluate that by taking 5 and raising it to the 1/3. Okay, now if you have the nth root of x and it's all being raised to a power, well, I know that the nth root of x, that's the same thing as x to the 1 over n. Now all of this is being raised to the a. Whenever you have a power raised to a power, what do you do to these two things? You multiply them. So a times 1 over n is the same thing as x to the a over n. So what's the pattern that we should recognize? If we have a number that's other than 1 in the numerator of this power, then that's what power it was all being raised to. The denominator is the root that it was taking. Okay? So if I said, let's do the fourth root of 17 all being cubed, I could rewrite that as 17 to what power? What should be the denominator in this power? The root, the 4. And the numerator should be the power that it was all being raised to. So 3. 17 to the 3/4 is the same thing as the fourth root of 17 cubed. Okay, so let's practice going from rational to radical form or radical to rational form. We know that these are in radical form because we have radical symbols. Yeah, it's like, oh, radical. All right, 3 to the 1/7. Okay, now how do I change that to radical form? So 3 to the 1/7 is the same thing as the 7th root of 3. And then all to the first power, so we don't have to write that 1. This is just the same thing as the 7th root of 3. So work backwards to figure out number 2. If I'm taking the cube root of 4, that's the same thing as 4 to what power? Exactly, to the 1/3. 3 to the 2 over 4, that would be the 4th root of 3 squared, which this is actually the same thing as just the square root of 3, because the 2 and the 4, they can cancel each other, because this is the same thing as 3 to the 1/2. Now, here's a quick question, because as we can see in the next example, we have a 2 on the outside and a 2 on the outside. If it's a 2, do you have to write that number? No, because Like if you have a radical symbol without a number on the outside, it's assumed that you're taking the square root. You only need the numbers for all the other times. So here we have the square root of 7, all raised to the 5th. So in rational form, that's 7 to the what power? 5 over 2. Alright, we're going to evaluate a few of these without a calculator. The first one that we're going to do is 16 to the 3 over 2. Okay, now, this is the same thing as the square root of 16 cubed. Now, here where the trick is that it doesn't matter. You could do the cubed first. You could take 16 and cube it, and then take the square root of that number. The only problem with that is 16 cubed is a huge number, right? That you probably don't know the square root of. It might be easier for us to do the square root first, and then cube that number. So, even though you can do it in any order, I would always suggest taking the root first, whatever root power it is, and then raising it if it's being raised to a power. So the square root of 16 is 4 cubed. So simplified, 4 cubed is 64. Okay, now let's try the cube root of negative 27 squared. Okay, so I could square negative 27 first and then take the cube root, but it's probably going to be easier to take the cube root of negative 27. So what's the cube root of negative 27? Well, what's the cube root of positive 27? 3. So the cube root of negative 27 is going to be negative 3. So now I have negative 3 squared. Well, negative 3 times negative 3 is positive 9. Alright, the last example will be the fourth root of 156 raised to the 4th power. Now, I don't know about you, but I don't know what 156 to the 4th power is off the top of my head, and I also don't know what the 4th root of 156 is. But isn't this the same thing as 156 to the 4 over 4? What's 4 over 4? 1. So this canceled that 4 on the outside. So it's just 156. Alright, now we're going to evaluate some with the calculator, and we'll round our answers to 2 decimal places. So let's do the cube root of 39. In my calculator, I'm going to type that in as 39 to the 1/3 power. So after we type that in, 39 caret to the 1 over 3, this comes out to about 3.39. Alright, negative 18 to the 1/5, it's already in rational form, so we can just type it in exactly like that. We get negative 1.78. Right, the last one that we'll do, let's do the 4th root of 125 cubed. So if I want to rewrite this in rational form, that way I can type it into the calculator easier. That'd be 125 raised to what power? 3 over 4 to the 3/4 power. This comes out to about 37.38. Okay, finally, let's talk about solving equations. Whenever we have an equal sign, we're trying to figure out what x equals, or whatever variable it is. Something to remember is that if the nth root is even, like, so if you're taking a square root or a fourth root of something, you have to remember to do plus or minus. If it's odd, you don't have to do plus or minus. So let's just jump right into this. Let's do 2x to the 6th equals 1,458. Okay, now it's important that I remember all my solving equations rules, especially from whenever we did solving by square roots. Since I see an x to the 6th, I know at some point in this I'm going to take the 6th root. Okay? Now, I can only take that 6th root if this x to the 6th is there by itself. Okay? Or whatever's being raised to the power is by itself. It might be an x plus 2 to the 6th or something like that. So as of right now, I've got this 2 hanging out that I need it to go away before I can do anything. So if x to the 6th is being multiplied by 2, how do I get rid of the 2? I divide both sides by 2. So we have x to the 6th is equal to 729. Now, I can take the 6th root of both sides. That's the same thing as raising each side to what power? To the 1/6. And if you think about it, if I raise both sides to the 1/6, what's 6 times 1/6? 1. Right? So I'd just be left with x. So that's where the whole taking the 6th root comes from. So I could have written it like that, or I could have written it as the 6th root. Anyways, now those things are going to cancel each other. And I am left over with x equals... Now, the 6th root, is that an even or an odd? It was even, so I need to remember to do plus or minus. And then 729 to the 1/6 power is 3. So x equals plus or minus 3. Okay, now I can change it up a little bit and say x plus 4 cubed equals 12. Okay, so my first step here is there anything on the outside of whatever's being cubed on this left-hand side? No, there's nothing outside this parentheses being multiplied, and there's nothing being added or subtracted. So I'm ready to take the cube root. So I could either, like in the last example, write both sides to the 1/3 power, or this is the same thing, just writing cube root. Okay. Now, what's going to happen is that this cube root cancels this cube. So I have x plus 4 is equal to the cube root of 12. Cube root of 12 is the same thing as 12 to the 1/3. It doesn't matter how you write it. So now if I'm going to solve for x, I would say x equals the cube root of 12 minus 4. Okay, so at this point I would go to my calculator. I would do 12 raised to the 1/3 power, and then minus 4 to get x is about equal to negative 1.71. Also, why did I not have to do plus or minus whenever I took the cube root? Because that's an odd. Alright, let's do one last example. We'll do y minus 3 to the 4th power equals 200. Okay, there's nothing on this side that is not being raised to the 4th. So I don't have to divide by anything or subtract or add anything. I'm ready to take the 4th root. So I'm ready to take the 4th root of each. Now since That way these cancel. Now since this is even, I know that y minus 3 equals the positive fourth root of 200, or y minus 3 equals the negative fourth root of 200. Right? Typically we just write plus or minus. And that's okay, because you could have written it y equals plus or minus the fourth root of 200. And then to move this 3 over, we added 3. So now, in your calculator, you would do y equals 200 to the 1/4 plus 3, and y equals negative 200 to the 1/4 plus 3. Whatever 200 to the 1/4 is, you need a positive and a negative one of those. Then you'll just add 3. So y equals about 6.76 and about negative 0.76. So with those evens, if you have plus or minus, how many answers will you have? 2. Alright, and that's all we're going to do today.